Now students, this is my 15th lecture of electrochemistry, class +2. In this lecture, I'm going to discuss a very important equation, that is Nernst equation. And we have already got information about electrode potential and the factors on which electrode potential depends. We know that electrode potential of any electrode is affected by concentration of its own ions, and we got information that electrode potential, that is reduction potential, is directly proportional to the molar concentration of its ions. So in this lecture we will determine with the help of expression how reduction potential is directly related to the molar concentration of ions. Not only this, we also know that electrode potential is affected by temperature. तो ये जो equation अब मैं आपसे discuss करने जा रहा हूँ, ये simultaneously it gives effect of temperature and concentration on electrode potential. Now let us see this equation. First of all, I'm going to discuss this for electrodes. Let us take a general expression that Mn positive plus n electron gives M solid. Remember, we generally, it's not mandatory, we generally use reduction term while finding expression for effect of concentration on electrode potential. So I have written equation of reduction term, that is Mn positive plus n electron gives M solid. So Nernst equation simply says electrode potential of that electrode at any concentration is equal to its standard electrode potential minus RT, R is a gas constant, T is a temperature, by n number of electrons transferred, F Faraday's constant, log base E, right? M solid over Mn positive. See this, E electrode means potential of electrode at any concentration is equal to E naught means standard value, which is measured at 298 Kelvin and 1 atmospheric pressure, minus RT, R gas constant, T by n number of electron transferred, and is very important term, log base E M solid over Mn positive aqueous concentration, that is its molar concentration. Now generally we consider concentration of pure solid substance or liquid substance or in the gaseous substance at 1 atmospheric pressure, their concentrations are taken as unity. So this solid, the concentration of M solid or M liquid, whatever, is taken as 1, okay, at 1 atmospheric pressure. So I can simply write E electrode is equal to E naught minus 2.303 RT by NF. I have changed the base of, now I'm taking log base 10. So when you take log base 10, we multiply the term with 2.303. So 2.303 RT by NF log of, this is taken as unity, 1 over Mn positive. Now guys, you have to remember this equation, fine? Now by using R, 8.314 joule mole inverse Kelvin inverse, and I'm using temperature here to be 298 Kelvin. You can find the effect of temperature by putting the temperature here. So जब हम इसको यहाँ fill करते हैं, we get this to be 0.0591 at 298 Kelvin. Remember. So मेरे पास क्या आ गया? E is equal to E naught minus 0.0591 by N log of 1 over Mn positive. Now see, N is simply number of electrons transferred during that reduction process. Fine. The first thing is we need to remember this equation. I simply apply it for any electrode. Say I use zinc electrode. For zinc, how can I write equation? Zinc ion aqueous. This is aqueous. This is in the solution form. Plus 2 electrons give zinc solid. So E zinc ion to zinc means electrode reduction potential of that electrode at any concentration is equal to E naught. You remember value of E naught for standard value of E naught for zinc electrode, that is minus 0.76 volt. Fine. So E zinc ion to zinc is equal to E naught, which is the standard value, minus 0.0591 by 2 log of 1 over zinc ion concentration. That is a molar concentration. Now by simply putting the value, how much is the concentration, you can find E naught cell, E naught electrode. Now I'm using 2 here. Why? Because number of electron transferred is 2. Okay. Now let us see. If I say the concentration of zinc ion is 0.1 molar, okay, 0.1 means 10 raised to power minus 1, right? अब ये ऊपर आके क्या बन जाएगा? 10. Log of 10 is 1. Okay. Then what is your potential? Electrode potential of zinc electrode? I write it here. E zinc ion to zinc is minus 0.76 minus 0.0591 by 2, because log of 10 is 1. Now what do you feel? See, this is minus 0.76 minus, if I this take upper value to be 0.06, this is minus 0.03. Now how much is this change? Minus 0.79 volt. Can you feel? ये वैल्यू और कम हो गया. क्या कम हुआ? रिडक्शन पोटेंशियल कम हो गया. क्यों? क्योंकि हमने यहां कंसंट्रेशन डिक्रीज कर दिया है. तो जितना उसके कॉरेस्पॉन्डिंग आयन का कंसंट्रेशन कम होगा, रिडक्शन पोटेंशियल उतना कम हो जाएगा. एग्जैक्टली अगर मैं ये वैल्यू 10 मोलर कर देता हूं तो क्या होगा? लॉग ऑफ 1 बाई 10, 10 ऊपर आए 10 माइनस 1, जब वो माइनस होगा 10 माइनस 1, लॉग ऑफ 10 रेज़ टू पावर माइनस 1, राइट? क्या अंडरस्टैंड कर रहे हैं? माइनस 0.76 माइनस 0.06 बाय 2 log of 10 raised to power minus 1. So this becomes 0.076 plus 0.06 by 2, that is 0.03. Now this is minus 0.076 plus 0.03. So this is minus 0.0. Just a minute, let me do a correction. This is 0.76. Fine. 0.76 plus 0.3, this is minus 0.734. So reduction potential has increased with the increase in concentration of zinc ion. तो अब अगर मैं यहाँ जिंक आयन का कंसंट्रेशन बढ़ा देता हूँ, ओके, पहले हमने इसको 0.1 मोलर लिया था, अब मैं इसको 10 मोलर कर देता हूँ. ठीक है, स्टैंडर्ड वैल्यू इज 1 मोलर ना. नाउ आई एम टेकिंग 10 मोलर. तो अगर मैं 0.1 मोलर ले रहा हूँ तो उसका क्या मतलब था, जो मैंने क्लियर किया, तो 1 मोलर से कम कर दिया. इसका मतलब जब आयन का कंसंट्रेशन कम हुआ तो रिडक्शन पोटेंशियल के ऊपर क्या इफेक्ट हुआ? रिडक्शन पोटेंशियल कम हो जाएगा. जैसे देखिए मैंने बताया, ये 0.1 मोलर लिया, जब ये 0.1 मोलर लिया तो log of 10 1 होता है, और मेरी टोटल वैल्यू माइनस 0.76 से कम होकर माइनस 0.79 वोल्ट हो गया. अब मैं इसको 10 मोलर करता हूँ, 1 मोलर से ज्यादा, तो ये क्या बन जाएगा? यहाँ स्पेस में लिख देते हैं, माइनस 0.76 माइनस 0.06 लिख देते हैं उसको, डिवाइडेड बाय 2 log of this log base 10 है, 10 raised to power minus 1. ये log m raised to power n log m होता है 0.76 माइनस माइनस प्लस 0.03, राइट? इसको 2 से डिवाइड किया तो ये माइनस 0.73 वोल्ट बन गया. नाउ यू कैन माइनस 0.73 वोल्ट बन गया. Now you can well observe यहाँ से रिडक्शन पोटेंशियल बढ़ गया. तो यही बात हम वहाँ थ्योरी में बतला रहे थे कि दैट रिडक्शन पोटेंशियल ऑफ इलेक्ट्रोड इज डायरेक्टली प्रोपोर्शनल टू द concentration of its molar ions. More the concentration of molar ions, more is the reduction potential. So definitely if reduction potential, value of reduction potential is increasing with the increase in concentration of its solution, then definitely oxidation potential will decrease with the increase in concentration of its ions. So remember, जितना ज़्यादा molar concentration उसके corresponding ion का होगा, reduction potential उतना ज़्यादा होगा, उतनी ज़्यादा reduce होने की tendency ज़्यादा होगी. And जितना concentration molar ion का ज़्यादा होगा, उसके solution के ions का concentration जिसका इलेक्ट्रोड बना है ज़्यादा होगा, ऑक्सीडेशन पोटेंशियल उतना कम होगा. मींस इलेक्ट्रोड के ऑक्सीडाइज होने के चांसेस की टेंडेंसी उतनी कम होती जाएगी. सो दिस इज एडवांटेज ऑफ नर्स्ट इक्वेशन. नाउ यू कैन सी दिस इज अ लीनियर इक्वेशन, y इज इक्वल टू c प्लस mx. ओके, तो ये rt by nf, ये दिस इज कमिंग आउट टू बी स्लोप विद लॉग बेस e. ओके, सो ये था इलेक्ट्रोड Nernst equation for electrodes. Exactly you can apply for copper electrode. See, copper ion plus 2 electron. I'm taking its reduction equation. Okay, copper ion plus 2 electron is copper solid. E copper ion to copper is E copper ion to copper. Standard value E naught value is minus 0.0591 by 2 because 2 electrons are being transferred. Log of 2. This by log of 1 over copper ion concentration. Because copper solid is taken as the unity for this case. Okay, hopefully this thing is clear. Now you can take any equation and simply apply to get result. आपको यहाँ पे न्यूमेरिकल मिलता है. अब इस पे थोड़ा सा आगे इसको मैं जो अप्लाई करने जा रहा हूँ, हाइड्रोजन इलेक्ट्रोड के ऊपर अप्लाई करने जा रहा हूँ. इट्स अ गुड रिजल्ट फॉर कॉम्पिटिशन. 2H positive plus 2 electron gives hydrogen gas. Okay, this is my equation. Then if you apply it for Nernst equation, then what we get, EH positive to H2 is equal to E naught, this is a standard value, minus 0.0591 by 2 log of, see the change. Okay, hydrogen ka, it's a gas, so I'm taking its pressure, right, divided by H positive raised to power 2 because this is its stoichiometry. Okay, so जितनी इसकी stoichiometry है उससे उसकी power बननी है. Don't forget to put this power here. Fine. Now we are taking pressure in this case to be 1 atmosphere or 1 bar. So I put 1 for pressure. Remember, if pressure is given to be different from 1 atmosphere or 1 bar, you need to put that value of pressure here. Remember, this is really very important for us. Then this is standard value of hydrogen electrode is 0.0 volt minus 0.0591 by 2 number of electron transferred log of 1 over H positive raised to power 2 था, उसको ऊपर ले गए, that becomes H positive raised to power minus 2. Okay, now if I simply observe, I bring this 2 here, log m raised to power n is n log m. 2 comes here, 2 by 2, 2 से 2 cancel out हो गया, so E is equal to minus 0.0591 by 2 into 2, 2 से 2 cancel हो गया, so E is equal to minus 0.0591 log of hydronium ion concentration raised to power minus 1. Now there is one important thing, what is pH? That is equal to minus log of hydronium ion solution, or we may write this to be log of H positive aqueous raised to power minus 1. Is that clear? Now what do you say? What is this? Log of H positive raised to power minus 1, this is pH. So instead of this term, we can put pH, okay, of that solution. इसका मतलब electrode potential is related to pH of solution. जितनी ज़्यादा pH होगी ये ओवरऑल वैल्यू उतनी नेगेटिव हो जाएगी, जितनी pH कम होगी राइट ये वैल्यू उतनी कम नेगेटिव होगी. सो वेरी इंपॉर्टेंट रिजल्ट फॉर कॉम्पिटिशन. ओके, सो समटाइम्स इट इज आस्क्ड find out electrode potential of hydrogen at pH 10, right? Yes, you can answer. If pH is 10, you multiply this with 10. Answer is minus 0.591. क्योंकि minus 0.0591 को 10 से मल्टीप्लाई किया तो कितना होगा? minus 0.591 वोल्ट इज द आंसर. सो इसको एप्लीकेशन के ऊपर किसी तरह भी हम यूज कर सकते हैं. Then comes the Nernst equation for galvanic cells. Here we have learned to apply Nernst equation to electrodes. Now I want to apply Nernst equation to cell. So before moving to cells, we must know cell has two parts. One oxidation half, second reduction half. So basically in a cell we have two electrodes. And what is E naught cell or simply E cell? किसी भी सेल का EMF क्या होगा? That is reduction potential of cathode half minus reduction potential of anode half. I repeat, what is E cell? Reduction potential of cathode half minus reduction potential of anode half. ये मैं conventional way ले रहा हूं क्योंकि यहाँ पे हम सभी इलेक्ट्रोड पोटेंशियल जो है वो रिडक्शन पोटेंशियल की सेंस में यूज कर रहे हैं. रिमेंबर, अदरवाइज यू नो द सिंपल वे टू फाइंड ईएमएफ ऑफ अ सेल, दैट इज रिडक्शन पोटेंशियल ऑफ दैट पार्ट व्हिच इज रिड्यूसिंग, दैट इज कैथोड, प्लस ऑक्सीडेशन पोटेंशियल ऑफ एनोड व्हिच शोज ऑक्सीडेशन. दिस इज द सिंपलेस्ट वे टू फाइंड ईएमएफ, बट कन्वेंशनली वी कंपेयर रिडक्शन पोटेंशियल्स ऑफ बोथ इलेक्ट्रोड्स. सो E cell is equal to reduction potential of cathode half minus reduction potential of anode half. I am comparing, I again say, I am comparing their reduction potentials. Is that clear? Now, in order to answer this case, let us take a Daniell cell. In Daniell cell, what we have? We have zinc rod dipped in zinc sulfate solution and copper rod dipped in copper sulfate solution. Okay? So if we take concentration to be 1 molar, then you get EMF, that is standard EMF of the cell. I want to know EMF of cell at concentration other than 1 molar concentration, or what happens to the EMF of cell if I increase the concentration of zinc ion or if I increase the concentration of copper ion. Now simply, in case of Daniell cell, we have two electrodes. One zinc electrode, other one is copper electrode. So how can we write EMF of a cell? That is equal to reduction potential of cathode half minus reduction potential of anode half. Okay, which part is cathode here? Okay, copper. So E copper ion to copper is reduction half, okay, cathode half, minus E zinc ion to zinc. I remember zinc ion to zinc, it's a reduction, okay, though oxidation is occurring on zinc electrode. Fine, because we are comparing their reduction potentials. Is that clear? So I repeat my words. E cell is equal to reduction potential of cathode half, which is copper, that is E copper ion to copper, minus reduction potential of anode half minus reduction potential of anode half, that is E zinc ion to zinc, though oxidation takes place at anode because we are comparing their reduction potentials. Okay, so E cell is equal to E copper ion to copper minus E zinc ion to zinc. May I know the E copper ion to copper? Of course, we did it for particular electrodes. that is E copper into copper is equal to E naught copper into copper. E naught is a standard value minus 0.0591 by 2 log of 1 over copper ion. Why 2? Because 2 electrons are transferred. And for zinc, it is written here, zinc ion plus 2 electrons to zinc. E zinc ion to zinc is E naught zinc ion to zinc minus 0.0591 by 2 log of 1 over zinc ion. Okay? Now you simply put down the values of E copper into copper and E zinc into zinc in this equation, okay, and solve it, simplify it. When you simplify this equation, you get E cell is equal to E naught cell minus 0.0591 by N, that is the number of electron transferred in the balanced equation, okay, log of, I repeat, E cell is equal to E naught cell minus 0.0591 by N, here N is 2, log of zinc ion concentration over copper ion concentration. Is that clear? Now you can see the result. So the easiest way to remember is simply write down balanced equation. So E cell is equal to E naught cell minus 0.0591 by N log of जो प्रोडक्ट साइड पे रिएक्शन के प्रोडक्ट साइड पे कंसंट्रेशन टर्म्स हैं वो ऊपर आ जाएंगी और जो रिएक्टेंट साइड पे वो नीचे आ जाएंगी और जो सॉलिड या प्योर सॉलिड या लिक्विड स्टेट में है उनकी कंसंट्रेशन हम यूनिटी ले लेते हैं और फाइनली मेरे पास रिजल्ट आ गया ई सेल इज इक्वल टू ई नॉट सेल minus 0.0591 by N log of zinc ion over copper ion. Remember, अगर यहाँ पे स्टोकियोमेट्री है कि जो भी यहाँ पे स्टोकियोमेट्री होगी वो वहाँ उनकी पावर बन जाएगी, जो मैं अपने नेक्स्ट लेक्चर में प्रॉब्लम के साथ आपके साथ इसको डिस्कस करूँगा. तो दिस इज ऑल अबाउट नर्स्ट इक्वेशन एंड यही हमारे टॉपिक के लास्ट वाले चैप्टर के लास्ट वाले कॉन्सेप्ट्स हैं जो कि इसके बाद नंबर ऑफ कॉन्सेप्ट जो है खत्म हो जाते हैं. सो जो भी पेपर में क्वेश्चन आएगा यही इन्हीं के बेस पे क्वेश्चन हमें पूछा जाना है. थैंक यू.